Again here, what we're looking at is evaluating limits that we believe are vertical asymptotes. If we plug in the number -3 into the function, -3 plus 3, we would get 0 in the denominator, which is undefined. That's a nice key characteristics of vertical asymptotes. When you plug in the number, you get an undefined. So let's consider our function x over 1x plus 3. And we're wanting to evaluate that function at numbers to the left and to the right of 3. So at the number, -3 is what I meant to say. At the number -3, we are undefined. So what happens as we approach it from the left? Well, that would be -3.1, -3.01, -3.001 would be approaching it from the left. -2.9, -2.99, and -2.999 would be values that I could approach it from the right. We're going to go ahead and use the table feature into our calculator, so go ahead and hit the table button, clear out any function you have, enter the new function, which is 1 over x plus 3, into your calculator, hit enter. Don't worry about start step, but make sure ask x is highlighted, hit OK, and then type in the values. If I plug in -3.1, I'm getting -10. If I plug in -3.01, I'm getting -100. And if I plug in -3.001, it looks like I'm getting -1000. So as I'm approaching 3 from the left-hand side, getting closer and closer, my y value is getting larger and larger, more negative. It's growing without bound in the negative direction. In other words, my limit's approaching negative infinity. That right there alone means that x equals -3 is a vertical asymptote for the function 1 over x plus 3. But let's go ahead and finish part B, which is approaching it from the right. Go back to your table. Let's now plug in -2.9. I'm getting 10. -2.99, I'm getting 100. -2.999, I'm getting 1000. So as I approach it from the right, as I approach -3 from the right, it seems my numbers are getting larger and larger, growing without bound towards the number infinity. So again, just because of the blue part here, we could say x equals -3 is a vertical asymptote. So if it tells us what the limit is, we can plug it in using the table feature just like we did at the beginning of the semester. These plugging in numbers verify that it is indeed a vertical asymptote because we're growing with or decreasing without bound. However, how do you tell if you have a vertical asymptote of a graph of a function when it's a rational function? Here's the key. Rational functions happen when the denominator is equal to 0. But first and most important is you must simplify first. You must simplify your function first. You must simplify the function before you find vertical asymptotes. So I'm writing that down now. So if I must simplify before, what do I mean by simplify? In this case, I just mean try to factor and simplify. So on top, I have x plus 4. That's perfectly fine. Nothing I can do there. But on bottom, it does look like I have an x in common. If I factored out, it would be an x times an x minus 4. Notice nothing in the numerator or denominator simplifies. So what I'm going to use is the simplified denominator. And I set the simplified denominator equal to 0 because that's where this function would be undefined. Again, vertical asymptotes occur when the function is undefined. So by setting the denominator, x times x minus 4 equal to 0, I have two separate factors, x equals 0, and I have x minus 4 equals 0. Adding 4 to both sides, I get x equals 4, and this gives me my two vertical asymptotes for this function. They are two separate asymptotes, x equals 0 and x equals 4. Remember, vertical asymptotes do have to be written as x equals. In other words, what you can't do is 0, 4 written like this, x equals 0, 4. That indicates that these are values of x's. These are not values of x's. These are actually lines, vertical lines that are vertical asymptotes. So that would be my two answers for that one, 0 and 4. Why do we want to be sure to factor and simplify first? Well, let's go ahead and look at the next example. Example 3 says determine all the vertical asymptotes of this. If I just sat here and said x squared minus 9 equals 0, when is this function undefined, I'd have x squared equals 9, taking the square root of both sides, remembering positive and negative, I'd have x equals plus and minus 3, or two separate vertical asymptotes, x equals negative 3 and x equals 3. We would have to write them as two separate numbers. However, I'm telling you, this is wrong. Never just start by setting the denominator equal to 0. Always factor and simplify first. So if we look at the numerator of our original function, we want to factor it and see what we get. Two numbers that multiply to be 3 and add to be 4. I think my factors I'm getting is x plus 3 and x plus 1. Foil that out to double check that that works. X squared plus x plus 3x would be x squared plus 4x. 3 times 1 is 3, so I'd have x squared plus 4x plus 3. That factors out properly. X squared minus 9 is a difference of squares. I know that factors into x plus 3 and x minus 3. So what do you notice? You have a common factor in the numerator and the denominator. Once I simplify those, I'm going to end up with f of x equals x plus 1 over x minus 3. This is the simplified version of the function, and this is what we use to find vertical asymptotes. All we do is set the denominator equal to 0. That's where this function would be undefined. So I set x minus 3 equal to 0, which gives me x equals 3. This is my only vertical asymptote for this function. Again, had I done it the original way, I would have gotten negative 3 and 3, which is incorrect. You could verify this by going to Desmos. Go to desmos.com, enter the original function in the graph, and what you're going to see is that negative 3, while the function is undefined because you would get 0 in the denominator, you'd actually have 0 over 0, the function is undefined, it would be something like a hole in the graph as opposed to a vertical asymptote of the graph. So anytime you have a common factor in the numerator and denominator, you're actually getting a hole rather than a vertical asymptote. The question asked us to find vertical asymptotes, so you need to make sure you factor and simplify first in each and every one of these problems. Let's continue on for the next ones. It says find the following limits. Essentially what they're doing is we're asking, what type of function is this? Do we have any vertical asymptotes at these points? So if I look at this function right here, this is really, well, they have an x in common, so that'd be x times x minus 4 all over x minus 2. They're having us evaluated at x equals 2, and notice if I plug in a 2, my denominator would be 0, which means it's undefined. If my function's undefined, that means I have a vertical asymptote. So x equals 2 is a vertical asymptote. Anytime I have a vertical asymptote, I know that the limit as x approaches 2 from the right or from the left of this function has to equal plus or minus infinity. So, vertical asymptotes, my limit's infinity or negative infinity. How do I find out what it is? Well, the nice thing is, all I need to do is test one point on each side, to the left and to the right, to determine whether it's positive or negative. So the first one says I need to plug in a number to the left of 2. How about, I don't know, 1.9. 1.9 is a number less than 2, so let's try plugging in 1.9. If I plugged in 1.9 squared minus 4 times 1.9, all over 1.9 minus 2, and I plug that into my calculator, I don't care what the actual number is. All I care about is this number positive or negative. Turns out this number is positive, so what does that mean? All numbers to the left would be positive, or as I approach 2 from the left, it's positive, and it's just going to get larger and larger and larger. That implies that the limit as x approaches 2 from the left-hand side of my function, x squared minus 4x all over x minus 2, has to be positive infinity. Because I got a positive number, I know it has to be positive infinity. Let's go on to the other one. We need to pick a number just to the right of 2, so how about something like 2.1? If I plug in 2.1, I'd have 2.1 squared minus 4 times 2.1, all over 2.1 minus 2. Again, all I care about is positive or negative in this case. Plug it into your calculator, and I'm getting a negative number. So what does that mean? As I approach 2 from the right-hand side and I get closer and closer to 2, I'm always going to have a negative value, and it's going to get more and more negative, which tells me that the limit as x approaches 2 from the right-hand side of this function, x squared minus 4x all over x minus 2, must be negative infinity. It approaches negative infinity. So if you know it's a vertical asymptote, you know it has to approach positive infinity or negative infinity. Which one does it approach? Well, plug in a number close to it to the left or to the right as it indicates. If you get a positive number, it approaches positive infinity. If you get a negative number, it approaches negative infinity. Again, if this wasn't something that you saw or noticed that it was a vertical asymptote, you could have done just like we did a couple previous examples ago with example 1, where you just do a sign chart, plug in the table, and plug in numbers getting closer and closer. You would have come to the exact same conclusion.